Hey, we are now at section B of your 2006 paper. Alright, let's go. So they tell you copper can be produced by heating copper to oxide in a stream of hydrogen. As shown, diagram over there, they give you a word equation. Now, when oxygen is lost, so your copper to oxide turns into copper, this change is called reduction. We come across it when we talk about the reduction of iron in your blast furnace. So if you're not sure about it, go and read. It is a similar concept. Part 2, everybody's favorite, mole concept. Mass of copper formed when 8 grams of copper oxide is placed in the boat. You want to find out your copper formed. Okay, first of all, you need a chemical equation. Copper to oxide, they gave you the formula, so don't think too hard. It is reacted with hydrogen. If you remember question 1, hydrogen is diatomic. And you get what they tell you on top, copper and water. Please, copper is Cu, don't tell me Cu2. Okay, that is a misconception. Plus H2O. That's water for you. Next, your calculation. First, you need to find your MR of copper oxide. Your copper to oxide is actually 64 for copper. It's the top number in your periodic table, just in case you forgot. Here you go. Copper is right here. Oxygen is right here. So I take the top number, which is your atomic mass. Add the two together, and I get 8T. So with this, I can start doing my maths. Step 1. Number of moles of copper to oxide. So mole of copper oxide is mass 8 grams divided by 8T, which we just calculated. So you get 0.1 mole. That is your step 1. As always, find mole. Step 2, your ratio happens to be very straightforward because you've got a 1:1 ratio. So how would I write it? Copper to oxide to copper is 1:1. So what does that mean? If I'm given 0.1 moles of copper to oxide, I will also get 0.1 moles of copper. Yay, we are half done. Finally, on to step 3. Step 3 is to find mass of copper. So mass of copper is moles times MR. 0.1 gotten from here times MR of copper. Look at your periodic table, 64, and we get our answer 6.4 grams. This has got a unit, don't forget. Okay, when you're done with that, look at part B, and they say that coins are made from copper mixed with other metals. What name do I call it? Alloy. Straightforward. Alloy. Why do you not use pure copper? Remember we learned that pure metals are soft? So that's your answer. Pure copper is too soft to be used in making coins. Simple. And then we've got the next page. A few more questions. Now, brass. Being a mixture of copper and zinc, you want to show how copper and zinc are arranged. So these two metals have got different size, right? So when you draw your diagram, you need to make sure that your diagram has got particles of different size. That's number one. Number two, you want to make sure that your arrangement is irregular, even for solid, because the arrangement is, I hope you came up with the word, disrupted. Okay, so let's draw it in. I've got, let's say, first layer. Maybe I try to make it a bit irregular now, and then I put a slightly bigger one inside somewhere, so it jumbles up my arrangement. Okay, it should look a bit more irregular than this, but mine is a bit messy. Okay, so copper, just for the simplicity, I'll make it the smaller one. And for complexity's sake, let me shade the slightly bigger ones and call this zinc. Okay, this is not the best example, but you get the idea. It must be irregular, and you need to show the two different size atoms. Very closely packed, because this is still a solid. Okay? And part C. Why is it important to recycle metals? Because metals do not last forever. Right? So this is straight from your notes if you actually have it with you. Why do you want to recycle metals? You want to conserve the limited amount of metals on Earth. Okay, very simple answer for a classic question. With this, we're done with question 5.